Hello, welcome to this video on synthetic division, where we'll introduce how synthetic division works as an alternative to polynomial division. So first on this screen is a polynomial, and it's asking if x equals 2 is a root. This is typically how polynomial division problems start. We check if something's a root, and then we factor it out. So synthetic division will give us an alternative to polynomial division to factor out roots. But first, let's check if it's a root. So to do that, we look at our original polynomial, and everywhere we have an x, we're just going to plug in a 2. So we get 2 to the 4th plus 2 cubed minus 11 times 2 squared minus 5 times 2 plus 30. And now we'll simplify this. 2 to the 4th is 16 plus 8 minus 44 minus 10 plus 30. And then when you group terms together, it's easy to see that this will become 0. So x minus 2 is a root. And by the remainder theorem, that tells us that x minus 2 is a factor. And so as a review, we'll start with an example on regular polynomial division, and then use that to compare how synthetic division differs. So we set up x minus 2. We write our polynomial in there. So that's x to the 4th plus x cubed minus 11x squared minus 5x plus 30. And then we just start to match what's going on. So we take x, we want to match that to x to the 4th. So we need to multiply that by x cubed. And we get x to the 4th minus 2x cubed, because we multiply that to the entire term. That gives us 3x cubed, and we bring down 11x. And now we have to multiply or add on our next term that will multiply to x minus 2 to match 3x cubed. So that will be a 3x squared. Multiply that through, we get 3x squared minus 6x. Sorry, 3x cubed minus 6x squared. We subtract that entire term, left with negative 5x squared, and we bring down a 5x. Now, again, we want to match, so we need to subtract 5x in this case. Give us negative 5x squared. And then we multiply that negative 5, and we get 10x. Give us 5x. Oh, my apologies. It won't be 5x. We want to be careful and subtract this entire term. That gives us negative 15x plus 30. And then to match x to minus 15x, we need to add on a minus 15. So it's minus 15x plus 30. We subtract, and we get a remainder of 0, which is exactly what we wanted because this is a factor. So that tells us that the polynomial we started with, that x to the 4th plus x cubed minus 11x squared minus 5x plus 30 equals x minus 2 times x cubed plus 3x squared minus 5x minus 15. And there we have it. We have successfully factored out one root from our polynomial. Now, this polynomial division took up a lot of space. There is a shorter way to do it, and it's by working solely with coefficients instead of dealing with all of these x terms running around. And that's through a technique called synthetic division. So for synthetic division, we're going to start with looking at our polynomial and just taking the coefficients. So we have 1, 1, minus 11, minus 5, and 30. So those are our coefficients. Now, we draw this little box, but upside down. And the number that we want to check is a root. We're going to put right here as just 2. So now we're not worrying about it being x minus 2. We're just putting 2. We're going to start with bringing down this 1. So essentially, we're just ignoring that we're trying to match that first term. But now we're going to multiply 2 to that 1 and bring a 2 up here. And now we add those two numbers together, and that brings down a 3. Then we multiply a 2 to that 3. That gives us a 6 and brings down a negative 5. Then we multiply a 2 to that negative 5. That brings down a negative 10. We add those together, we get minus 15. We multiply a 2 to that negative 15. We get negative 30. We add those together, we get 0. Now this is where the interesting thing comes into play, where now this 0, that's what becomes known as our remainder, which is exactly what we had before, a remainder of 0. That allows us to conclude that 2 is a root, and we actually got the coefficients of the new polynomial. So this tells us that the polynomial should be x cubed plus 3x squared minus 5x minus 15, which matches what we had above. So that's all we had to do for synthetic division. So it's a lot faster, but it does obscure what's going on. So synthetic means something that is not real, something that's made like plastics are a synthetic. And so that's kind of what it's getting at with this technique, where this doesn't feel like real division. Instead, this is a technique that has taken polynomial division and boiled it down to just its bones that we care about. We've gotten rid of anything else that doesn't matter. There's no x's lying around. And so for a little obscurity, we have gained speed. This technique can be really, really fast. As just evidenced here, we only had to write down a few numbers and it saved a lot of space, but it's just a lot harder to see what's going on. But in general, the 0 at the end, it tells us it's a remainder. If we had something that was not a 0, so if not 0, that implies not a root. And the only other problem with synthetic division is that it's hard to do. It's not that clear what to do when you have higher than a first degree polynomial. So theoretically, there is a way out there to do it with a quadratic, but it's really tough and just makes it easier to do normal polynomial division. But it can be fast when you're just trying to factor out a single root. All right, so that's synthetic division. I hope that helped. Yeah, and have a good day.